Building a flawlessly coded, elegantly designed application with zero bugs is a total waste of time if it solves the wrong problem. How do engineers lock down exactly what a client needs before writing a single line of code? Let's follow a case study to find out. We'll track the development of SafeHome, a web-based smart security system, to see how a vague idea transforms into a technical blueprint. That transformation happens through requirements engineering. It is the mandatory bridge between what the business wants and what the technical team actually deploys. The process starts with the inception phase. This is where you identify the core business need and figure out exactly who the stakeholders are. For SafeHome, the outcome of inception is answering basic questions to form a single, clear problem statement, like, we need a web-based smart home security dashboard. At this stage, you are not discussing specific features. You are only figuring out the overarching goal and identifying the people you need to interview to get there. Establishing a rigid boundary around the core problem right out of the gate prevents scope creep from taking over before the project even begins. Next comes elicitation. This is the collaborative process of extracting raw data, desired features, and usage scenarios directly from stakeholders. The friction here is that stakeholders frequently omit obvious details or make contradictory requests. High-security encryption makes instant sub-second logins nearly impossible. To fix this, we move to elaboration. This translates raw, unstructured client requests into developer-friendly, structured models. For SafeHome, we parse requests to identify system objects, like the control panel, and the services that manipulate them, like arm, disarm, or trigger alarm. Without this step, developers have no way to translate contradictory client speak into actionable software architecture. Once the models are built, you hit reality. Requested project features will always exceed the available time and budget. This triggers the negotiation phase. Negotiation is not about telling the client no. It is the process of prioritizing features to reach a win-win compromise. Stakeholders use a priority point system, ranking features to determine what makes the final cut for the current release and what gets delayed. Pause the video and answer this. If marketing wants a 3D interface, but engineering warns of a 6-month delay, in which phase is this resolved, and what is the primary goal? This is resolved in the negotiation phase. The goal is to reach a prioritized win-win compromise. That compromise is then documented in the specification phase. This acts as a binding contract detailing what will actually be built. A specification does not have to be a massive textbook. For smaller projects, it can simply be a lightweight collection of validated models and usage scenarios. This document serves as the definitive source of truth, locking in client expectations and defining the exact parameters developers need for the coding phase. Before handing that specification off to the programmers, you must perform validation. This is a final technical review to catch ambiguity, omissions, and logical errors. Validation checks the theoretical blueprint before development begins, whereas software testing checks the actual code after development is finished. For instance, if a requirement says the system must be fast, validation flags it. You strike out the subjective request and replace it with a testable metric, like the system must load the camera feed in under 2 seconds. Together, these steps form the requirements analysis funnel, distilling business needs into a technical blueprint. Inception defines the boundary. Elicitation gathers raw requests. Elaboration structures them into models. Negotiation prioritizes against constraints. Specification documents the compromise. Validation checks the math. Adhering strictly to this pipeline guarantees that the software delivered to the client is exactly the software required by the business.